So we'll start the session with the recap of the concept of scalar product or dot product. So we've seen that it is defined by this simple operation. The dot product of A and B is nothing but magnitude of A multiplied by magnitude of B multiplied by cos of theta, where theta is the angle between them. And to that effect, we had seen that A dot B is a scalar quantity which can be positive, negative, or zero. Positive when the angle is acute, negative when the angle is obtuse, and zero when the angle is 90 degrees. So this is something we'd seen. Then of course we had seen the dot product in component notation. Seen that it's given by the simple formula ax bx plus ay by plus az bz, where ax, ay, and az are the components of the vector A. Bx, by, and bz are the components of the vector B. So this was what we had learned about dot product, more or less. Apart from that, we had seen various things like it follows the distributive property, it follows the commutative property, etc. So let's look at some example questions first, then we'll come back to the assignment. So for example, now if it is given to us that magnitude of vector E is 12, magnitude of vector B is 16, and magnitude of A plus B is 20, then find E dot B. Just try this out. Very simple question as a revision of the concepts that we've learned earlier. This is just connecting up the concept of triangle law of vector addition and the concept of dot product. Just see if you can try this out. Yes, Harshul and Chitij, your answers are correct, both of you. Anybody else? Harshal and Chitij have both got the correct answers. Yes, Mac correct. Kanish correct. So yes, Mayank and Kanish, both of you have got the answers correct also. So it's very simple. यहाँ पे क्या use करना है? We know that the definition of A dot B is AB cos theta. So we just need the value of cos theta. We know that A dot B is defined as AB cos theta. Whereas we also know that mod of A plus B is defined as root of A square plus B square plus 2AB cos theta. So use this information that is given over here. So mod of A plus B is given to us as 20, and that is root of 12 square plus 16 square plus 2 into 12 into 16 cos theta. You can square both the sides and you will see that 400 is equal to 400 plus 2 times AB cos theta basically. This term is, you can see that cos theta is 0. That is, they are perpendicular. Going back there, A dot B will become 0. So that becomes the simple solution. Right. Similarly, let's look at another example, which is like the reverse of this. Now it is given to us that magnitude of A is equal to magnitude of B is equal to 10, and A dot B is equal to minus 50. Then find A plus B is 2, A minus B, and the angle between A and B. So these are some mixed type of questions, where we have to utilize a lot of concepts based on all the things we've learned so far. These 3 different angles also we have to find. Okay, people, so got the answers for this? Yeah, I'll just check out what people have written. Yes, Kanishk, answer is correct. Mod A plus B will be correct. A minus B is also correct. The first two angles you have got. Yeah, Kshitij, correct. Very good. Kshitij, first वाले का आंसर एक बार चेक करो. Mod A plus B is to mod A minus B. That one, just check your answer first. Your angles are correct. Yes, Varun, that's correct. Yeah, the angle is correct for the A part. Yes, it is, now the answer is correct. The ratio is now correct. Okay. So various different ways by which you can do this question. Okay. So the simplest method I'm telling you what logic you can follow. Now, okay, it is given, yeah, that magnitude of A is equal to magnitude of B is equal to 10, and A dot B, which is AB cos theta, is minus 50. So that means cos theta is minus half, which means theta is 120 degrees. This should be very obvious to all of you because you know that cos 60 is half. So naturally cos 120 becomes minus cos 60 or minus half. Theta is the angle between two vectors. It can either be acute or obtuse or 90 degrees. It cannot be in third quadrant or fourth quadrant. So there are only these two possibilities. So here, since A dot B is negative, that means it has to be obtuse. So going on this, okay. Now, as far as magnitude of A plus B is concerned and magnitude of A minus B is concerned, because mod A is equal to mod B, you can use the rhombus rule, the rhombus principle. So in the rhombus, you just visualize that is this sort of a rhombus. Equal sides of 10, but the angle is 120 degrees. So that way you can get all the answers by just following the principles of the geometry of the rhombus. You can save a lot of time in solving all of this. You can see this vector A plus B will be such that this angle here, this will be bisecting this angle 60 degrees, and this vector here will be bisecting this angle, so this will be 30 degrees, and also they will be mutually perpendicular. And you can reduce this formula. So it will become 10. can see that by using the Rhombus principle, we can simplify it this way. Okay. Otherwise, we would have to use the formula of the triangle law, which would have given us the same thing, but would have given us a little bit more lengthy solution. So, for example, if we did not use the Rhombus formula, then we would have been stuck with these formulas, that mod of a plus b is root of a square plus b square plus 2ab cos theta. So यहाँ पे that would become 10 square plus 10 square plus 2 into 10 into 10 into cos 120, which is minus half. So then that would have given us 10. And then the formula for tan alpha ऐसा जाता. So this would have come as root 3. So that means alpha would have come as 60 degrees. And from this, same way for solving for tan beta, you would have got beta as 30 degrees. And that would have told you that these two are perpendicular to each other. So it would have been a more lengthy way of solving the question. Now, another approach we could have taken here is we could have taken the component approach also. We take the component algebra approach. So let us say the vector A is suppose 10 I cap, and the vector B is also of magnitude 10. So let us say it is 10 cos theta I cap plus 10 sin theta, because it's given to us that both are of magnitude 10. So this is the vector A of 10. And the vector B is at some assumed angle theta to it. And it's also magnitude 10. So from here we could have seen that A dot B is AX BX plus AY BY. So that would have been 100 cos theta. And that is given as minus 50. So from that we would have figured out that okay, cos theta is minus half. So that means theta is equal to 120 degrees. And that also means that the vector B would have become minus 5 I cap plus 5 root 3 j cap. So this is now my vector B. So now I can use component algebra. So I can see that E plus B, therefore, will become 10 minus 5, so that's 5 I cap plus 5 root 3 j cap. So magnitude of A plus B is equal to 10. And E minus B would have become 10 minus minus 5, so that is 15 I cap, and 0 minus, so minus 5 root 3 j cap. So now calculating this mod, I would have got this as 10 root 3. So this is done. And similarly, now we could use dot product to find the angles also. So how we can use dot product to find the angles? You can see that now you want to find the angle between A and B, that you already done. It's 120 degrees. Now you want to find the angle between E plus B and A minus B. So calculate the dot product. So keep in mind I've written A plus B and A minus B down here below. So what is the dot product of A plus B and A minus B? दोनों के x components का product, so that is how much? 15 times 75. So plus 75 plus the product of the y components, which is 5 root 3 into 5 root 3. That's 25 into 375, but with a minus sign. So minus 75. So the dot product is 0. That means what is the angle? Angle between them is 90 degrees. That's done. Okay. And similarly, you want to find the angle between the vector E plus B, which is 5 I cap plus 5 root 3 j cap, and the vector E, which was 10 I cap. You can see that this angle will be tan inverse of 5 root 3 by 5, or 60 degrees, because you can see that the vector E would have been lying along the x-axis like this, whereas the vector E plus B, you just draw it over here like this. So this is the angle alpha we're talking about. And this vector is given to us as 5 I cap plus 5 root 3 j cap. So obviously that angle alpha is 60 degrees. So that's yet another method. But out of all this, you can see the most convenient method is if we were able to directly recognize that mod A is equal to mod B, that means their vector parallelogram is a rhombus, and use the special properties of rhombus. That will always give us the fastest and simplest way of solving such a question. So that is the advantage of, first of all, knowing parallelogram law, and then knowing the special cases of parallelogram law, like the rhombus case, the rectangle case, which we have discussed in detail. So that was one of the reasons why we discussed all these things. Okay, so that's a quick recap of last time. Now, I think we have 2 worksheets pending because we had 2 lectures which were back to back. So let us go back to worksheet number 5, I think, right? The revision worksheet number 5. We have both 5 and 6 which we have to discuss, if I'm not mistaken. Is that correct, people? Yes. Assignment 5 and 6 both are pending, right, in discussion. So let's try to complete the discussion of assignment 5 at least today. Okay, so assignment 5, I'm starting with question number 2. Anybody has a doubt in question 1? Assignment 5, people, anybody has a doubt in question 1? Okay. So question 2, unfortunately, there's a misprint in the assignment sheet from my side. So that's why your answer will probably not be matching, but I'll tell you how to do the question anyway. So first of all, make this correction in question number 5. Sorry, question number 2. Question 2, make this correction that the first displacement that is given 80 kilometers towards east, change that from 80 to 140. Okay. So A is a displacement. Okay, I'll come to question 1 also, and just let me complete with this. Okay. So A is a displacement. It is given 80 kilometers, but make a correction. Change that to 140 kilometers. That was a misprint in the question paper. I mean, in the worksheet, to the east. And now I think you'll be able to solve it. Just try it out. B is a displacement of 60 root 2 kilometers towards northwest. So we have to find the magnitude of the net displacement. So we have to find mod of A plus B. So if you tried this question with this as 80, you would not have got any of the answers in the options. But just try it now, you should be able to get. So you can use either component algebra or you can use triangle law, whichever you like. So just try out this question. In the meanwhile, I'm just making a diagram to understand it better. Okay. So vector E अगर ऐसा है, that it's 140 kilometers towards this direction, east. Then vector B in my diagram will become like this. Something like this. It should be exactly between north and west. When we say northwest, it means 45 degrees north of west, or 45 degrees west of north. So this angle should be 45 degrees. And its magnitude is 60. So northwest means 45 degrees north of west, or west of north, whatever. So my resultant will now become this. This is A plus B. So we want to find the magnitude of this. So we can invoke triangle law, or we can use component algebra, whichever suits us. If we go by triangle law, the angle between A and B is this one. So that is 135 degrees. So if you go by triangle law method, magnitude of A will be 140, magnitude of B will be 60 root 2, and the angle between them will be 135 degrees. So you know that cos 135 will be minus 1 by root 2. So mod of A plus B. Because वो northwest दिया होता है ना बेटा, the direction of B was given northwest now. So A is pointing towards east. Okay now. And B is pointing towards northwest. So northwest means it should bisect north and west. So that means this angle should be 45. This angle should be 45. So this total angle becomes. So 140 square plus 60 root 2 का whole square plus 2 into 140 into 60 root 2 into minus 1 by root 2. So we can take 10 common outside. We get 14 square plus 72 minus, ये कितना हो जाएगा? Whatever. So solving this, we will get this as 100. We can also go with the component method. With the component method, we will express the vector E as 140 I cap, and the vector B will become minus 60 I cap plus 60 j cap. Okay. Just verify this component thing that I've written from the diagram, and you'll understand why B is like this. If you take this as your x-axis and the north direction as your y-axis, you'll understand B is like this. So you can see that E plus B will become 140 minus 60, that is 80 I cap plus 60 j cap. So here this is comparatively easier. Like this. Okay, we will hope this is clear to all of you. We'll discuss the first question. Okay, so question number 1 says that the vector E is given by the relation I cap minus root 3 j cap. And we want to find the angle with respect to the positive x-axis. Find the angle of vector E with respect to the positive x-axis. This is what we want to do. Okay. So two methods. One is that we can just use formula. Formula-based method is that theta is tan inverse of Ay by Ax, which here will become tan inverse minus root 3. That's one thing. And secondly, that since Ax is plus 1, that is it's positive, and Ay is minus root 3, therefore it is negative. Therefore, theta is in third quadrant. In fourth quadrant. X component positive or Y component negative, that means it's in fourth quadrant. So we'll use the formula for the fourth quadrant, that tan of theta is minus of tan 360 minus theta. So that is equal to minus root 3. So that means tan of 360 minus theta is root 3, which means that 360 minus theta is tan inverse of root 3, which is 60 degrees. That means theta is equal to 300. Or that can also be written as minus 60 degrees. Anti-clockwise of 300 is the same thing as clockwise of 600 or 60. So that is the formula-based method, which is very tedious and not the very best way of solving. The easier way is just to draw the vector. So understand it geometrically. So we understand geometrically the vector E, which is I cap minus root 3 j cap. Just draw it in the xy plane and you understand very easily what kind of angle it meets with the x-axis. Now this vector should be such that its x component is I cap. So let's say that's this. And its y component is minus root 3 I cap. So its y component is like this. Minus root 3 j cap. So the vector is the sum of these two components. Will be this one here. This is becoming my vector. So you can see that this is the angle we are talking about. This angle is alpha, this angle is theta. So theta is 360 degrees minus alpha or just minus alpha. Now when you look at this in more detail, when you look at this triangle, you can also understand that this is a right angle triangle such that this is 1 and this is root 3, this triangle. And this angle is alpha. So you can see that tan alpha is root 3. So that means alpha is 60 degrees. So coming back here with a proper algebraic sign or with a proper notation, you can see that theta with respect to the positive x-axis is 300 degrees. Or we can also express it as minus 60 degrees. Whichever form the answer is given, that should be marked. If both the answers are given 300 and minus 60, then both the options have to be marked. So that is the meaning of this. So remember, when we are talking about angle with respect to positive x-axis in a two-dimensional plane, we always following that sign convention that anti-clockwise is positive and clockwise is negative. So we cannot give the angle as 60 degrees over here. Okay? With the proper sign convention, we have to either give it as plus 300 degrees or minus 60 degrees. 60 degrees would have been in first quadrant, but this is in fourth quadrant, so it is minus 60 or plus 300. Because why beta na? Because 360 is equivalent to 0 na? You can see in the diagram na? Whether you go anti-clockwise by theta or clockwise by alpha, you are at the same position. Understood, Harshal? From the x-axis, आप या तो 300 degrees anti-clockwise घुमा रहे हो, या 60 degrees clockwise घुमा रहे हो. Your vector A is following the same position, na? Understood, Amita? That's why. So that is why any angle theta is equivalent to negative of 360 minus theta. Now, if I say the angle is 120, that's equivalent to saying it is minus 240. Or if I say the angle is 270 degrees, it's equivalent to saying that it's minus 90 degrees. Okay, because a clockwise rotation of so much is equivalent to an anti-clockwise rotation of 360 minus alpha. Okay, so this question is clear, people. Okay, so these are the final points about trigonometry, okay, angles in 4 quadrants and vector algebra. And actually understanding vector algebra will clear a lot of things about your trigonometry in 4 quadrants. Okay, next what are we doing? First and second is done. Third question, anybody has a doubt or you're clear? Third, fourth, fifth. Okay, third one, I'll just give you a simple suggestion what to do in the question. See, third question is just a matter of just bit of manipulation. और कुछ नहीं करना है. It is given to us in the question that E plus B is equal to minus 4A. And this is what is given to us. What you do is transfer A to that side. So that means B is equal to minus 5A. So that means, see, when you multiply a vector with a negative quantity, it becomes opposite in direction. That means B is opposite to A and magnitude of B is 5 times magnitude of A. So that means that if the vector E is some vector like this, okay, then the vector B must be like this. It must be opposite in direction and 5 times in magnitude. Okay. Or you could draw vector B somewhere else also, it doesn't matter. Vector B could be drawn here also. But as long as it's understood that it's anti-parallel or it is opposite in direction. So therefore the angle between them is 180 degrees to 0. ठीक है, Mayank, is it clear now? Okay, have you understood this better? Whereas, for example, if I said that there's another vector, suppose I say C is equal to 2 times E, then that is different. Now C will be parallel to E. C will be like this now. C will be along E's direction, but 2 times in magnitude. So C will be at 0 degrees with respect to E, or it will be what we call parallel. But the magnitude of C will be twice of the magnitude. Alright, what about fourth and fifth? Anyone has a doubt in fourth or fifth question, people? Fifth. Okay, let's come to question 5 then. So it says magnitude of A plus B is greater than magnitude of A minus B. Which of the following must be correct? So magnitude of A plus B is greater than magnitude of A minus B. If we go by formula based method, we can say that root of A square plus B square plus 2AB cos theta is greater than root of A square plus B square minus 2AB cos theta. So square both the sides. This must be greater than A square plus B square. So that means 4AB cos theta is greater than 0. Now E is basically what? It's magnitude of a vector, so it can't be negative. E is magnitude of a vector, it can't be negative. 4 is just a number, it's a positive number. So this can only conclude one thing, that cos theta is positive. Which can only conclude one thing, that theta is between 0 and 9. So this is the formula based method. Okay. Now the thing is that you should not have to do so much effort. You also understand from parallelogram law, we had seen that if you have a parallelogram with 90-degree angle, then the diagonals are equal. If you have a parallelogram with acute angle, then the primary diagonal is longer. नहीं बेटा यहाँ पे we have to understand one thing. Theta is not the angle with the x-axis. No, theta is the angle between two vectors. So the angle between two vectors, remember, cannot exceed 180 degrees. Vectors कैसे भी हो, एक वेक्टर यहाँ पे हो, एक वेक्टर ऐसा हो, you'll always take the angle between them as this one. You won't take the angle as this one. Understood the point? No? So unless we are talking about theta as the angle with respect to the x-axis, we are talking about theta as the angle between two vectors. It only has a range up to 180 degrees. We take the smaller of the two. We don't take the larger. So if I say the angle between two vectors is 120, it wouldn't be wrong to say that it's 240. But we will always write it as 120. We take the smaller of the two. Or if the angle between two vectors is 60, we won't say that it's 300. We just say it's 60. So if you compare these type of parallelograms, three parallelograms where in one of them theta is acute, in one of them theta is 90, and in one of them theta is obtuse. Now when you draw the primary diagonal, you'll see that in this one it is longest. In this one it is equal to the secondary diagonal. In this one it becomes shorter than the secondary diagonal. So if you're just able to visualize these parallelograms, it will be clear to you which one is the case. So just this simple visualization of three cases where magnitude of A and B are same in all three of them. All three have the same A and the same B in magnitude, but different angles. So you'll see that in this case, the primary diagonal is longer. In the acute angle case, it is greater than mod A minus B. In this case, this is equal to the secondary diagonal. And in this case, actually, the primary diagonal becomes shorter in length compared to the secondary diagonal. So this case they were talking about was the first of the three. So theta had to be acute. So the only conclusive statement we can make that when mod A plus B is greater than mod A minus B, the only conclusive statement we can make is that the angle between the two vectors must be an acute angle. Okay, so that was question number 5. Okay, next, any other questions? 6, 7, 8, etc. Okay. Okay, 6 we'll discuss. Okay, so see people, in sixth question, what you can do is, since it is given to you that the resultant of P and Q is such that R is perpendicular to E, you can, one simple method is you can draw the vector triangle for R as the sum of P and Q, and that will be a right angle triangle, because R is perpendicular to P. And then you can invoke Pythagoras theorem in that. Or you can use trigonometry, and from that you will get whatever is required. The other is you can use component algebra. Because P is perpendicular to R, take the vector P to be along x-axis, the vector R to be along y-axis, and write them in component form. Both methods are equally easy over here. Just give this a try, I'll discuss. Okay, so got the question? So R is perpendicular to, it should not be A, it should be P. And P and Q are in the ratio 3:5. So let's say this is our vector P. So the resultant is perpendicular to P, like this. So Q must be this one. So mod P is to mod Q. Is given as, there is some mix up of symbols in the question. Okay, there should not be A and B. There should not be A and P, and instead there should be P and Q. So wherever there is A, B, just replace it with P and Q. Okay. So it's like if this is 3x, then this is 5x, and we have to find this thing, the angle between P and Q, theta. So you can find that easily. You can find it this way, that you can see that cos theta is minus of cos alpha, and in the diagram you can see that is cos alpha is, so alpha is equal to 53 degrees. So that means theta is equal to 127 degrees. You people understood the sixth question? Okay, next. Seventh is very easy. I think it's based on theorem only. What about eighth question? Yeah, question 7, 8. These are clear, people. Please let me know, otherwise I will solve. Okay, so then I will come to the ninth question. Okay, Ansh, question number 8. Okay, let's discuss. Okay, I should just wait a minute, people, to note down question number 6, then we'll come back to 8. Okay, so moving on to question number 8, it says this. So from that we have to find the angle between them. So just invoke the triangle law. Okay. So mod of a minus b is root of a square plus b square minus 2ab cos theta. Just use this over here. So 7 is equal to 12 square plus 5 square minus 2 into 12 into 5 into cos theta. So 49 is equal to 144 plus 25 minus 120 cos theta. So you see cos theta will come out to be minus 1 when you calculate this. This will tell you that 49 is equal to 169 minus 120 cos theta. Or oh sorry, cos theta will come out to be plus 1 minus. Cos theta is coming out to be plus 1. So that means theta is how much? It is 0. Now you can also check that for theta equal to 0, magnitude of a minus b actually becomes this. And that's correct. Because this is 12 minus 5 magnitude 7. From triangle inequality and triangle law, we've seen these things before. So if that thing had struck you here itself, no, you could have avoided all this calculation. You can see over here that 7 is equal to 12 minus 5. So that means magnitude of a minus b is equal to the difference of their magnitudes. So this means that theta is equal to 0 directly. You could have avoided all this. Yes, that's correct, Sarah. 8th over here. Now we'll come to question 9. Okay, so question 9 I will discuss in two methods. One is the general principle of solving it. The other is the shortcut method we use. So question 9 में बोला है that vector E is 12 I cap plus 16 j cap, and the vector B is 7 j cap. You want to find the angle between A and B. So the first method, most fundamental one, is geometrically. So if we were to draw these vectors geometrically, we'd understand that the vector A which is 12 I cap plus 16 j cap. So that vector is something like this. You can see that this angle will be 53 degrees because I mean this is 16, this is 12. You can see that tan 53. From that you can see that that angle is 53. Whereas the vector b like this is lying along the y-axis. So that is along the y-axis. So now which angle we are looking for? The angle between A and B. So that is this angle theta. So you can see very simply that theta is equal to 90 minus 53 or 30 centimeters. Okay. This is the primary way of solving this particular question because you can see it's quite easy. One of the vectors already along the y-axis. It's very easy to calculate the angle between A and B. However, there are a couple of more methods and I'd like you to try those methods also. Okay. So the second method, I'll just give you a hint. In method 2, use the formula A dot B is equal to AB cos theta to find theta. Use this. Just try it by this method. Okay, so done. Yeah, I'm coming to this. So I'll just explain this method to the rest of you. So इसमें देखो क्या करो. Let's just take this below you. So the vector E was given to us as 12 I cap plus 16 j cap, and the vector B was given to us as 7 j cap. So from this we can see that magnitude of the vector E is 20. From this we can see that the magnitude of the vector B is 7. And from this we can see that E dot B, given by the formula Ax Bx plus Ay By, is how much? It is 84 plus 0. So it's 84 basically. So now use this concept that A dot B is equal to AB cos theta. That means cos theta is equal to A dot B divided by magnitude of A into magnitude of B. So substitute A dot B from here. Substitute mod A from here. Mod B from here. Which one is wrong? So cos theta will come out to be 84 divided by yeah, it's wrong. Correct. Thanks for pointing out this is wrong. So this will be 12 into 0 plus 16 into 7. Correct? Because B's x component is 0 and B's y component is 7. Okay. So E dot B is equal to 112. So cos theta is equal to 4 by 5. That means that theta is equal to. So this is a more preferable method of finding the angle between two vectors. So this is an easy way of finding the angle between two vectors. Cos theta is equal to E dot B divided by EB. This is a useful formula for finding theta when E and B are in component form. It's a useful method. If 10th question I think is easy, you can handle it yourself. Let's come to 11th question. Okay, people. So ninth question is clear to all of you. I hope this was the ninth question, and 10th I think is pretty easy, so you can handle it. Let's come to question 11. So 11th question is vector E plus P is given to us. Yeah, Ganesh confirmed. So this is something pretty important. Let's make a note of this. Okay. So let's come to 11th question. It's saying that E plus B is 5 I cap and E minus B is 5 root 3 J cap. So we have to find magnitude of E. Okay, 10 I'll come back to. Okay. So let's also extend this question. So let's also find magnitude of B, okay, the angle theta between A and B. Let's do all this. Okay. So there are a couple of ways of doing this. One is you can if you just observe that E plus B is perpendicular to E minus B, because one is along the x-axis, one is along the y-axis. So what does it imply? That the parallelogram is a rhombus. We use those special theorems because diagonals are perpendicular. Okay. So that means magnitude of A is equal to magnitude of B, such that magnitude of A plus B is 2A cos theta by 2, and magnitude of A minus B is 2A sin theta by 2. Now this is 5 and this is 5 root 3. Because you can see this. So solving these two equations, so if you do equation 2 divided by equation 1, you will get tan theta by 2 is root 3, which means theta by 2 is 60, which means theta is 120 degrees. So that means 2A cos 60 is equal to 5. So magnitude of A is equal to 5. So mod A is equal to mod B is equal to 5, and theta is equal to 120 degrees. Okay. This is the easiest way of solving this question, where you are again just making use of your previous knowledge. The trick that whenever A plus B is perpendicular to A minus B, it means that if you visualize the vector parallelogram, the diagonals must be perpendicular. So that means it must be a rhombus. And then you are just making use of the properties of rhombus. Okay. So hope this method is clear to all of you. Alright, another thing we can do here, alternately is also do like this. Given that A plus B was equal to 5 I cap, let's say that's equation 1, and A minus B was 5 root 3 j cap, let's say that's equation 2, add the two equations, equation 1 plus equation 2. So what we'll get? We'll get 2A is equal to 5 I cap plus 5 root 3 j cap. So that means A is equal to 5 by 2 I cap plus 5 root 3 by 2 j cap. So the magnitude of the vector E So this is another way of solving the same question. Okay, understood. Now, similarly over here, we could have also found out if you subtract the two equations, 1 minus 2 अगर कर दो, so you will get 2b is 5 I cap minus 5 root 3 j cap. So the vector b will become 5 by 2 I cap minus 5 root 3 by 2 j cap, which will also show you what we discussed earlier, that the magnitude of b is equal to the magnitude of b. Both will come out to be 5. Okay. And now from this you can find the angle between them. And you can see that since mod A is equal to mod B is equal to 5 and A plus B is also equal to 5, that means theta must be 120 degrees, because they must be forming an equilateral triangle. So in this particular question, you are not asked to find out all this, but just telling you, you can get the background information. So the angle between A and B, remember, will be the exterior angle, this one. So this will have to be 120 degrees, because these three angles are all 60. Okay, so we'll come to question 13, Harshal. But before that, we'll go back to question 10, because Mayank has asked question 10 also. Okay, so question 10 is saying that the resultant of A plus B is such that the resultant is perpendicular to E, and the magnitude of the resultant is 0.75 times the magnitude of E. Then we have to find we can do this in a number of ways. For example, if you draw a vector triangle, it will have to be like this. So the magnitude of B is this. So in this you can see that B will be square root of E square plus 0.75 E का whole square. So 0.75 can be written as 3 by 4. So you can see that magnitude of B is this. So E is to B will become 4:5. A simple way of solving it. Okay, so I hope this is clear. You can also use component algebra. So you can also do by components. You take vector E as some E I cap. So E plus B, or the resultant, becomes, no, today the rest of the thing is just about discussion of questions. The new part was what we discussed earlier on. So this is 0.75 E G cap. Okay. So from this you can see that the vector B is this resultant minus E. So it is 0.75 E. Yeah, it's fine. Kanish, that's okay. The worksheet number 6 I will be discussing in the next lecture. Okay. So you can see that magnitude of B will become square root of E square plus 0.75 E square. So that's giving you the same. Okay, so that's question 10. Now moving on to question 13. So F1 and F2 are at 60 degrees to each other in the horizontal plane. Yeah, you can, Sarah, no problem. Another 10 minutes anyway. So they are in the horizontal plane of 5 newtons each. Their magnitude is, sorry, is 4 newtons each. And F3 is a vertical force, also of magnitude 4 newtons. F3 is vertical and of 4 Newton magnitude. So we have to find the resultant's magnitude. Okay, so we have to find how we'll do this. Okay, so we have to understand this in 3 dimensions properly. So suppose this is my horizontal plane. So this is the horizontal plane, and this here is my vertical line. Okay. Then my F1 and F2 are lying in the horizontal plane, but at an angle of 60 degrees. and they're of magnitude 4 newtons each. Whereas my force F3 is along the vertical. So F3 over here is like this. It is perpendicular to this one also, it is perpendicular to this one also. So we can just develop a system of coordinates. We can develop a coordinate axis system wherein, let us say that this is our y-axis. This is our x-axis, and this is our z-axis. So z-axis is vertical, and the xy plane is the horizontal plane. So you can see that F1 and F2 lie in the horizontal plane. The diagram here, you can easily understand that the vectors F1 and F2 are lying in the horizontal plane. That means they are in the xy plane. Such that F1 is along x-axis and F2 is at 60 degrees to x-axis. So F1 as a vector component form thing will become how much? It will become 4 I cap in newtons. Whereas F2 will become 4 cos 60, so that is 2 plus 4 sin 60, that is 2 root 3 j cap, because here we use x component of this will become 4 cos 60 and y component of this will become 4 sin 60. Okay. Whereas F3 on the other hand is a different thing altogether. F3 is not in the xy plane. F3 is perpendicular to the xy plane, lying along the z axis. So F3 is vertical. So therefore it is along the z axis. Vertical means it does not have any x and y component. No horizontal component. So that means F3, its magnitude is 4, but its direction is along the z axis. So it's like this in newtons. Okay, so just make sure you understood this diagram and these steps first, and then all we have to do is use vector addition and component notation to add these things. Okay, so once you found these in component form, now next step is very simple. Just add them up. So F1 plus F2 plus F3 is becoming how much? 4 plus 2 plus 0. So that's 6 I cap plus 0 plus 2 root 3 plus 0. So that's 2 root 3 j cap plus 0 plus 0 plus 4. So that's 4 theta. Okay. So magnitude of the vector sum is just coming from this. So that's 36 plus 12 plus 16. So that is square root of 36 plus 28. Okay, so that nearly completes the exercise. Any other question? I think 14 is very easy, and 15 is also rather easy. You have to just substitute in the formula. So for 14, just put mod of a, that is root of x component square plus y component square plus z component square, and substitute. You will get the formula for, and you will get a single equation for z. Similarly, 15 you just directly use triangle now. Okay, so just note this down, and in case you haven't completed 14, 15, just go through the questions. I'll explain if required. Okay, people. So hope this is clear. And as I said, question 14 and 15 is very easy. So in question 14, you have to just use the formula of mod A. So that is that root of 2 square plus 1 square plus z square. That will become 3. So from that you will get the value of z. And in 15th, then it's something very simple. You have to just use triangle law. E minus B का formula निकालना है. So just use that formula. Root of A square plus B square minus 2AB cos theta. So fairly simple stuff. You can complete this exercise. Okay. And more importantly, now move on to exercise 6. The assignment 6, which is going to be based on a lot of the things we discussed about dot product today, and also about the angle between two vectors, how to calculate using dot product. That concept I taught you, that cos theta is equal to A dot B divided by AB. So how to make use of that. That is also something important. So just revise that section and then try out the questions of assignment 6, and we'll pick it up from there in the next lecture. That's it for today. Thank you. Achha, by the way, you can also do some questions from your from your module exercises. I will send you along with the notes. I'll send you a list of questions from exercise 1 and 2, which you should attempt from the module. Okay, the vectors module, exercise 1 and 2. There are a lot of questions that you can work out now using this. Okay.